Again, welcome to data mining course. In this lectures, we're going to discuss about using R to build a decision tree models. And we are going to discuss three types of decision tree algorithms, which the first one will be the CART, C-A-R-T, and the second one will be the C5.0, which in Waker we call the J48 algorithm. And the last one will be the random forest. So again, first we start with the introduction to decision tree, the definition. So here we say a decision tree consists of a set of decision nodes. And these decision nodes are connected by branches. And it extends downward from the root node until terminating in a leaf node. So normally in a decision tree, we begin with the root node, which is at the top. And we keep going through until, again, we reach the leaf section. And each section, we are going to split our data. Now, selecting the right variable, which we say the optimal variable for the splitting, will depend on the Gini index. Again, if we are using the CART. And also we have what we call the entropy and information gain. And these are some probability algorithm or formula that we can use, again, to decide what attribute or what variable we are going to use to split again, the decision trees. We discussed this in our normal lectures textbook. Again, these lectures will more focus on a hands-on using the R. So decision tree classification tags, again, decision tree is a supervised learning algorithm or classification tags, which means we need the training data to build the model. Then we use the test set data to test the model, how accurate it is. So an example here is that we have a data set here, which is the training set. And we are going to use the training set to build our model. So we are going to apply the decision tree algorithm or the tree induction algorithm with a training data set. A training data set is a data set that also consists of the class variable, or we say the target variable. An example here, we have a data set about taxpayers. So again, the first attribute or the column is TID, which stands for the tax ID. Then we have attribute 1, 2, 3, and the last one will be whether the taxpayer cheat on tax or not. So the answer is yes or no. Most decision tree algorithms give us a binary decision: true, false, yes, no, positive, or negative. So the red column data is our target variable. Sometimes also we use the term class variable. So that's our decision. Now, when you look at the test set, you can see that on the class variable, we don't have anything. So now the algorithm, the model that we are going to build using the training set and the decision tree algorithm, that model now is going to make a decision for us. It's going to predict, give us the right answer. Again, sometimes we may not get 100% correct answer. We are at least hoping for at least 80, 90%, 95% perfect. So this is how the data set look again. So here we have our training set again. And based on the decision tree algorithm, we're able to build this tree. So which means based on the either the Gini index number or the entropy or info gain, we were able to select. Again, when we're using the Gini index, the goal is to have the purity. Again, we discussed this in our lectures. So here we are assuming the refund is the best attribute to use to split. So here we have a refund, yes or no. Based on the data set, we know that if a taxpayer gets a refund, surely it's not going to cheat. So we don't need to test any variable no more. But when the refund is no, which means there's a possibility that the taxpayer will cheat. But we cannot decide based on the data set here, the algorithm cannot decide. So we need to select our next variable that we are going to use for splitting. And based on the algorithm, the optimal decision is based on this variable named marriage status. So if your marriage status is single or divorced, or you are married, you are not going to cheat on tax. So which means if I don't get no refund, but I'm married, I'm not going to cheat on the tax. But if I don't get no refund and I'm not married, or I'm divorced, I'm single or divorced, which means I'm not married, and also my taxable income is less than 80,000, then I'm not going to cheat. But if my taxable income is greater than 80,000, then I'm going to cheat. So this is how the algorithm work, the decision tree algorithm works. Now we use that, the first thing we build here, this is just the model. So we use the training set to build the model. Now we are going to test it, how accurate it is. So now we have one data set here. The test set, there's no refund. The taxpayer is married. His taxable income is 80,000, but we don't know if it's yes or no for cheat. So now the decision tree model that we build with the training set is going to make a decision. So it's the same decision tree we have. This is the model now. So we put in the data set, and based on this data set, the refund is no. So it will go this direction. So refund is no. So we go through the direction. And also the marriage status is no. So, oh, sorry, it's married. So we go this direction. So that means the decision here will be no. So we can say assign cheat to no based on the model that we build. So the decision tree classification task, again, is two steps. The classification task or supervised learning is always two steps. First, we need a training set to build our model. Then after we build a model, then we are going to use the test set to test the model, how accurate it is. So we start with the first decision tree algorithm, which we call the CAT, or classification and regression trees. This is one of the earliest decision tree algorithms, somewhere around earlier 1980s. It was developed. So the concept here is that we are going to recursively partition the training set into subsets with similar values, again, for the target variable. And normally we are going to gross the tree by conducting exhaustive search of all variables, or all the possible available variables, and all the possible splitting values. And the CAT algorithm normally use the Gini index to split again the data set. So again, a CAT model normally will produce a decision tree that are strictly binary. It's always binary. And it will contain exactly two branches for each decision code because again, it's binary. And CAT again recursively partitions the records in the training data set into subset of records with similar values for the target variable. So again, as we said, the CAT algorithm normally will gross the tree by conducting for each decision node an exhaustive search of all available variables and also all possible splitting values, selecting again the optimal split according to Gini index. So this is our main objective of the lectures. How do we build a CAT decision trees using, again, the R? So the first column we see is just we're trying to get our data, getting at our data. So the first thing here we are trying to do is, again, import the training data set. And the training data set name is a.tr, which is right here. So we are trying to import a.tr. Now, once the data is loaded into the R, we are going to rename it as a marital status. Marital status. So we can see here, we have marital status assigned to a.tr, column names. Then the next thing we're going to do is again to change. So the column names here, this column names command normally will list the names of each of the variables in the a.tr data set. So here we have a marital status. Again, we are assuming we already done this. We have the marital status. So we assign it to a.tr, which is our data set. But column names, again, is a command. It's a command. So column names, what column names will do is that it will list the names of each of the variables in the a.tr data set. Then it will run on its own, and also it will output the column names in order. We should know that the first column contains the marital status variable. So using 1, again, if we use 1 at the end of the column name a.tr, it will isolate the variable name for the marital status, and that's what we are doing here. We are using 1 here. So again, what this one means is at the end of the column names a.tr data set, it will isolate the variable name for the marital status. That's the first variable. Then we can rename it, the variable, by creating the marital status and also save it as the variable's name. And then we can change both categorical variable to factors. So that's what we are doing. So this factor again is to change the data structure type to factors. So we change the a.tr. Income will be a variable again as a factors. Marital status also as a factors. So now our data set is ready to build a model. So the next thing, we are going to run the cat, but before that, we need to install the package for cat. So here we say install and open the original package, rpat, and also rpat.plot. So again, the package for cat is the rpat. So first we use the command install.package, and we know the C function combine two or more elements together. So we use the C function, which we also call the combine function. We have the rpat and also rpat.plot. Then semicolon. Then we have the part again and the library. We know the library when we I miss L here, supposed to be library. We saw it in our previous introduction to R that if we want to use any package, for example, here we are doing cat. First thing we need to do is to install the package using the install.packages. So if I'm using the R Studio, we can use the menu to install the package. Then if we install the package, if we want to use it, we use the command library. So here I have two packages here. So library rpat and library rpat.plot. So now we have our package now. Next step is to build a model. So we are building the model into Carton. So we have our object on the right side. Now we are using the R part now. So we have our part. We have, again, these are the variables in our data set. So the formula here, we say equal to income, marital status, plus cap gains, losses, comma. This should be the formula. Then the data equal to, again, we are using the a.tr. And the method is the class. So again, here we are building the model. Again, the package for building the cat decision tree in R is called the rpat. And the main reason why we are using the rpat plot, this will give you the option to visualize, to plot our tree, and to see our tree, to plot it as we saw the previous slides. So the formula has a structure: target and the predictors. Target, predictors. So again, the former input has the structure for target, predictors, where again the names of the predictors are separated by plus sign. So the plus sign you see here is the name of the predictors are separated by the plus sign. And the data input will specify which data set the variable are coming from. So we saw a data input, data equal to a.tr. So again, the data input specify which data set the variables are coming from. And also the last section, which is the method equal to class. The method class input will specify that we want to use classification cat model. Classification cat model. That's why it's class classification. Then finally, we save the resulting model as cat01. It's up to you. You can save it as any name. So again, this is the model. And we can see the separating variables with the plus. The data here tell us where our data set is coming from, a.tr. We already load it. Beginning, we have to load the a.tr. Then also method equal to, this means classification. We are using classification cat. Then finally, we save the model, as we said, as cat01. Now, once the cat model is built, we can also plot the cat model with the default display option using the rpath.plot command. Remember, we also install it. Again, if I don't need to plot the decision tree that we develop, I can just import only the rpath. Again, the rpath is the cat decision tree package. Then rpath.plot is the package to plot the cat decision tree. So if I want to plot it, all I need to do, remember our model now, we assign it to cat01 variable. So I will use that as an argument, rpath.plot cat01 to plot it. So this command again takes as only require input the name under which we save the cat model. So again, that's the whole concept here. The goal here again is to build the cat model. This is where my cursor is. Again, this is where we build the model. But of course, we need the data to build the model. So from the beginning, is loading our data and also changing variable to factor data structure. Now, the next step is that to classify each record, we can create a data frame. Again, we know data frame is one of the advanced R data structure that include the predictor variables of the records you wish to classify. So here we have data.frame. We need the marital status. And again, a.tr is our data set, and the marital status is our variable. We also have the cap gains losses, which is also in the a.tr data set, and the variable name again, cap gains losses. Then we can use the predict command again to do our prediction. So here we want to predict. The object is the model that we build. Now we have a new data set that we're going to build. So new data equal to X. The type again is classification. So again, to obtain the classification for each record in the data set using the cat model, we first need to create a data frame, and that's what we did. That includes the predictor variables of the records you wish to classify. Now the data X here contains the two predictor variables that we use to build a cat model. Also, it's very important that the variable name in the new data frame exactly match the variable name used to build a cat model. Then we can use the predict method or function command to build it. So now let's move to the next section. How do we build C5.0 decision tree? Again, this is another decision tree algorithm called the C5.0. This is the same algorithm as J48 in Waker. So again, the steps are the same. If we know how to build any model in R, the most important thing is we should know the package name. If we know the package, I think the rest is straightforward. So first, we need the data. Second, we have to install the package. Third, we have to use the library function in order to use the package to build our model. So here we can see that we skip the previous slide. We show the steps how to load our data into R. Here we skip it. So we are assuming the data is already loaded in the R. So next step, we are going to install the package named C50. C50. So in R, the C5.0 is named 650. We want to use it, so we have to use the command library C50. So next step is to build the model now. So we call the model C5. And we use the command C5.0. Again, the same concept. We have the formula equal to the income, marital status, then the cap gains losses. Those are the variables we are going to use. Then remember, we are using the same data set, A.tr. So we have A.tr control, C5.0 control mean cases equal to, again, 75. And then here we say the formula is identical to its cat counterpart. So data equal to A.tr. So again, in order to do this step, we make sure that we do not change the marital status variable name or convert the categorical variables to factors. If we haven't done so, we need to do so. So that is the same, as I said, the same steps as the previous cat. Then we install again the package C50. We want to use it, so we use the library command. Then if we want to run the algorithm, we use the C5.0 command, which is right here, C5.0 command. It takes the argument. The argument will be, again, we specify the variables in our data set, etc. So here the core input value is variable input. Is the formula input. The input for the C5.0 is the formula input, which is again identical to the cat counterpart, the same thing as we did for the cat. And also as before, as the cat, the target variable is to the left of the tilde. So target variable to the left of the tilde. So our income. And the predictor variable is to the right, separated by plus sign. So this means my target variable, I want to predict for income based on the person's, whether it's married or not, marital status, and also cap gains losses. So we have two variables that will predict the income for us. So the data equal to TR, which is right here, data equal to TR, input will specify that we are drawing our variables from the A.tr data set. That's all. Remember, A.tr is our data set, same as the previous. And the control equal to C5.0 control mean cases equal to 75. Again, this input required the leaf nodes. the leaf nodes in the decision tree to have at least 75 records. So that's why it's minimum, mean cases. The leaf nodes should have at least 75 records in the decision tree. Then we save this resulting again to C5. Again, that's the name C5. So our result will be on C5. Now, if we want to plot it, we just use the plot command, plot C5, to see how our decision tree look like. If we want to predict the same concept, we use the predict command. So to obtain classification for each record in the data set, we should run the predict. So in this case, I'm going to say predict the object equal to C5. Remember C5, our model. Now same thing, we are using the new data X. Okay, so the next one, which is the last one, will be the random forest. So we know random forest normally builds a series of decision trees and need to combine the classification of each record into a one final decision tree. So again, CAT and C5.0 both produce a single decision tree. The CAT and C5.0 both produces a single decision tree based on all of the records. But again, random forest normally would build a series of decision tree and combine the trees and disparate classification of each record into one final decision tree. So random forests, again, are an example of assembly method. Again, we discussed this in our lectures. Assemble methods are a category of modeling techniques that take multiple models output into, again, account in order to arrive at a single answer. So random forests are an example of, again, ensemble method, modeling techniques that take multiple models output into account in order to arrive at single. So build a decision tree using a random sample with replacement from the original training data. Now for each node, a subset of predictor variables are considered. Then the trees are used to classify records in original training. So yeah, let's see how we can build a random forest again model using the R. So the same step, as we said earlier, most important thing is we should know the package's name. So random forest, the package name is also called random forest. It's case sensitive. R is case sensitive, so F is uppercase. So again, here we are assuming the same step, even if you are using Python, also the same Waker, also the same step. When we're using the Waker to build our model, the first thing we have to get our data. We need the data. Then we do our data preparation, which in Waker we call it the filtering. After we finish the preparation, then we apply our algorithm. Same thing with the R. So we skip that step again. We need to load our data. And also we can do data preparation with R. Which we call the data wangling. There's packages for doing that. But again, for now, we skip. We will cover that in the future. So again, install.packages, random forest. I want to use it, so I use the library command to get ready to use it. Next step, I'm going to run the random forest algorithm. So the same thing, we are using the formula, the same predictor variable income, the same responded the variable marital status, cap gains, losses. And we are using data equal to a.tr. Our data set is coming from a data set named a.tr. Then the number of trees we're going to produce here will be 100. And the type, of course, is classification. So again, as I said earlier from beginning, the same step. If we haven't changed the marital status variable, we need to convert it to categorical variable as we did in the CAT model, then later to factors. We install and open. That's the two steps here, install and open the random forest package. Now we run the random forest algorithm using the formula input as before again. And the command to build a random forest again is random forest. So we can see random forest, build a random forest. So that's what we have here, random forest. So again, that will be the conclusion of our lectures. Again, in these lectures, we just went through the steps how we can use the R to build decision tree, three different algorithms. The CAT, which is one of the earliest algorithm in decision tree, then C5.0, and then the random forest. So again, wish everybody the best and thank you for your time.